Hello students, I'm sure you have all gone through that PPT and the video links which we had shared with you. In this particular video, I'm going to talk about intrinsic semiconductor. I had shared a video link with you. If you have gone through that video link, I'm sure after watching this video, your doubts will be cleared. So if you remember, an intrinsic semiconductor is a one which is a pure semiconductor, and usually these are made of materials like silicon and germanium. So basically an intrinsic semiconductor will have a lattice made of silicon atoms only and germanium atoms. Now for silicon, the atomic number is 14. So therefore its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3p2. And for germanium, the atomic number is 32. Hence its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p2. So what you see over here is that both for silicon here and for the germanium, in the valence shell, the outermost shell, which is the third shell in the case of silicon, and it is the fourth shell in the case of germanium, where there should have been 8 electrons as per the octet rule, but actually there are 4 electrons only, which means that both for silicon and germanium they're short of 4 electrons in order to complete the octet rule, or in order to have 8 electrons in their outermost shell. So what they do is that these germanium or the silicon atoms, they share the electrons with each other. So I've drawn this lattice structure of germanium, where you can see that each germanium atom is bonded via covalent bonds with the neighboring 4 germanium atoms. So basically this germanium atom is sharing the 4 electrons from these germanium atoms, and these are the 4 electrons, or these are the 4 electrons of the germanium atom. Okay, so sharing means that this particular electron which belongs to this germanium atom is shuttling between this and this, which means it is moving between this germanium atom and then going back here, and then again coming back here, and then going back here. So it's continuously shuttling between this and this germanium atom. Similarly, in this case also, this electron is continuously shuttling between this germanium atom and this. So it's moving back and forth between the 2 germanium atoms. So whenever this electron is with this germanium atom and the rest of the electrons are also with this germanium atoms, then this germanium atoms completes the 8 electrons in the outermost shell. Okay, so this way, by forming the 4 covalent bonds, the germanium atom therefore completes or obeys the octet rule. Alright, now see that under normal circumstances